Hi everybody, it's crazy, it's Monday, and it's time for the UPBGE video of the week. Now before I get started, gotta give a shout out to my trusted because you guys rock. To my crazy fam, I love you guys. Now we're up to episode number 121, and we left off last week at the bottom of page 40. I'm gonna switch, no, not that one, there we go. Switch over here to the bottom of page 40, and we're gonna start with game interaction. That's what we did last week. The file you're going to be using is from the game engine folder, okay, and you're going to do the walkthrough underscore base, and it's the camera navigation.blend, and it's got all the information here of everything you need to know, okay? So let's go ahead and get started. Okay, game interaction, camera underscore navigation dot change view, okay, the outcome of the functions. Camera underscore navigation move camera underscore navigation dot look underscore camera, and camera underscore navigation dot orbit underscore camera. Okay, if you're following through in the book, if you're not, link is in the description to get the book. Make sure you get the files along with the book. Don't just get the book and think you're going to be able to go through all this, because you're not going to know what everything's going on. Make sure you get those files. Okay, all right, so in the previous section, we saw how the angles and directions were calculated with Python. However, we deliberately skipped the most important part, applying it to the game engine elements. It includes activating actuators, as we do in the change view function, or directly interfering in our game elements, cameras, and pivots. Outcome of the function, scripts.move camera underscore camera, scripts.look underscore camera, and scripts.orbit underscore camera. Let's put the pieces together now. We already know the camera future orientation and position. Therefore, it is almost nothing left to be calculated here. Nevertheless, there are distinct ways to change the object position and orientation. In move camera, which is down here at 336. Let's go ahead and make it down there. 330. There we go. 336 right here. I'm going to bring it up so you can see it because my big head's in the way. Let's scroll this up just a little bit so you can get a better view. So it's right up here, okay? Alright, so this is move camera. We are going to use an instance method of the pivot object called apply movement vector and local. This is part of the game engine methods. Another one is apply rotation, you will see next. We explain later in this chapter in the using the game engine API section. This built-in function translates the object using the vector path as a parameter. It can either be relative to the local or world coordinates, okay? So, as we go into it, we're going to go down to 356. That's these right here. Yeah, 356, okay? 357 and 358. We're working with the pivot points, okay? In a similar way, in the look camera function, okay, which is a little bit back up here, 269, right here, the look camera sensor, okay, function, we will apply the rotation in the camera object, okay. Let's see, 314. There he goes. Okay, that's this little guy right here. Okay, we're going to change that. This is the advantage of sparing the hassle of 3D math, matrices, and orientations. Also, instead of manually computing the new orientation matrix in Python, we can rely on the game engine C++ narrative, i.e. FAST, implementation for that task, okay? So basically, we are using the apply rotation, or there it is. Okay, we're using the camera.apply rotation and pivot.apply rotation. Okay, and we're putting them in there. Although we are leaving the math calculation to the game engine, we should still be aware of how it works. The apply rotation routine works with Euler angles as a gimbal machine. The effects for the walk and the fly modes are very similar. The only difference is whether the rotation is local or global and the axis to rotate around. Okay, so basically these little guys right here are what actually make it work. 22 calls them. Okay, scroll on down. Yeah, 22 to 27 does that. Does all the neat stuff there. Okay. In the orbit camera function, we calculated the orientation matrix of the pivot. This matrix is no more than a fancy mathematical way of describing a rotation. Since we already have the matrix, all we need to do is to set it to our pivot orientation. Okay, and that's 223 again. Okay, it's going up here, 220. There we go. Okay. Let me scroll down so I can see this one on this page, because it also goes to 261, which is right here, these guys. From here to here, okay? For some odd reason they left out, now we can use Ori as our new orientational matrix, okay? So the orientation is a Python built-in variable that can be read and written directly by our script. We will talk more about this in the Using the Game Engine API Application Programming Interface part of this chapter. Okay. Scripts.changeView. After the... hang on. Yeah, okay. After the user presses a key, 1, 2, or 3, to change the view, we call the change_view function to switch to the new camera, with a parameter specifying which camera to use. This function consists of two parts. First, we set the correct position and orientation for the camera and pivot. Secondly, we change the current camera to the new one. Okay? Decomposing the view orientation. Keep in mind that the desired orientation stored in the empty and accessed through the g.views dictionary represents the new view orientation. In our system, this view orientation is the combination of the parent object, the pivot, orientation with the child one, the camera. Let's start simple and build up as we go. First, the orbit camera. In the orbit mode, the camera is stationary. Its position never changes. Okay, so that's in 155. We're going to go on up here. Okay, 155. It's this little guy right here. Okay. All we need to do is reset the pivot orientation to its initial values. Its orientation was globally stored back in the init_world function. So now we can retrieve and apply it to the pivot. Okay, so what are you going to do is you're going to have that from the camera's orbit view. You're going to pivot from the dictionary and continue on. Okay. The fly camera is slightly different. Okay, and that's in 169, which is down here. Okay. In this case, the camera orientation contains no rotation, i.e., an identity matrix. Therefore, it's up to the pivot orientation to match the view orientation. In other words, the pivot orientation matrix is exactly the same as the view orientation matrix. For the walk camera, that's in 190, right there, the walk fly. Okay, we have yet another situation. The mode we are coming from, fly, has the camera pivot orientation, same as camera.world.orientation, as the current view orientation. However, for the walk mode, the pivot needs to be parallel to the ground. For that, we need to rotate it a few degrees to align with the horizon. the camera now will be looking at a different point above and below the orientation direction. In order to realign the camera with the view orientation, we need to rotate the camera in the opposite direction. This way, the pivot and camera rotations void each other, with the benefit of having the pivot now properly aligned with the ground. Okay, so that's what 190 to 190. Oops, got a cover behind me. I'm sorry. To 199. Okay. Reasoning behind the design. There's another reason for keeping this as a separate function. Originally, I was planning to switch modes, walk, fly, while keeping the same camera position and view. Although I dropped the idea, I decided to keep the system flexible in case of any turn of events. Clients who understands their minds. Now that the new camera and the pivot have a correct position and orientation, we can effectively switch cameras. That's 181. Okay, that's right here. Okay, for that, we first set the new camera in the scene. Set camera actuator. Okay, next we activate the actuator and the camera will change. Okay, so that was this one. More Python. Scripts.collision.check and scripts.stick to ground. The script system shown so far handles all the interaction from the game engine sensors to the 3D world elements. Even though this covers most parts of the typical script architecture, I'd be lying if I said this is all you will be doing for your projects. Very often you will need a script called once in a while that deals directly with the game engine data. In our case, we will have two high sensors to control the collision and thus stick our camera to the ground while walking. We could have them both working attached to an always sensor. However, this would not be efficient. Since we only need them while walking and flying, they can be integrated with the keyboard sensor pipeline. The stick to ground function will be called after any key is pressed if the current mode is walk. Okay? So if the current mode is walk, no matter what key you press, okay, 142, okay, is going to make that stick to the ground because of the fact it's in walk cycle. Okay, even if it's in walk fly mode, it'll transfer to walk. Okay, so if gnab.mode equals walk and g.walkFly equals walk, then you're going to stick to ground. Very simple. The collision system can be used even more specifically inside the move camera function. That is down here into 353 again. 353 right here, okay? Alright, so inside the move camera function, we will use the collision test to validate or discard our moving vector, okay? So this will either do it or not, okay? If the collision check test finds any obstacle in front of the camera, it returns a null vector, 0, 0, 0. Otherwise, it leaves the vector as it was set, which will then move the camera. The code of those functions is very particular to this project. Therefore, we're not going into more detail here. You are encouraged to take a look at the complete code in the book file, though. Okay, so check out the code. Nevertheless, the key point is to understand the role of those functions in the script architecture. Those scripts can complement the functionality of other functions to rule your game in a global and direct way, or simply to tie things together. Okay, so that's basically it. You want to go through the code and take a look at it. Try to figure out what each one of these are, and understand what each one of these are. Go back through the book and go back through all the numbers that I gave you in this video to show you. because believe it or not, it'll start making sense the more you understand it. Okay, reading over it, study a few more books even. That will help you. Go to the Blender API homepage, and it will show you a lot of this information. Okay, so that's about what we're going to do for today. I'm going to switch back over to here. We're going to end on page 45, reusing your script for next week. It's at the bottom of the page, so we'll do it at that. Reusing your script, bottom of page 45, next week. Till then.